Okay, so here's my Markov naming code. I read the data into data frames and then create a hash set of the original names to verify that our new names are truly new. So we can check that in order of 001 time. Here's where I get some user input. So male or female, minimum name length 4, maximum name length 10, 5 names generate. Okay, so here is my function to populate the Markov dict. So I just did it for the second order. So I go through the data frame that I pass in, then iterate over the tuples. The first entry in the tuple is just the index, which isn't interesting, so the name is the second thing, that's what I want. I convert it to a list of the characters, and then I go through the different parts of the name. So at the beginning of the name, I need to use underscore magic to get that in properly. Then I do the middle of the name up until length -2, and then deal with the actual end and add underscore again to signify the end of the name. So I just run this code on the particular gendered data frame, and I end up with something that looks like this. So just to check that it seems reasonable, so A begins girls' names most, sounds reasonable. M is pretty high up there. Q is low, that seems good to me. So this is a nested dictionary or underlying hash table structure, so I have fast lookup, like I said, because I don't like waiting for lookups. This means that A follows A at the beginning of a name one time. So here's my code to actually generate the name. So while the length of the name is less than the maximum name length, then we continue to try to append letters to this name. So we start with the key 2 underscores, and we check the entries in the dictionary for that key. We get the elements, which are the letters, and the weights, which are the number of times those occur. Then we calculate the updated weight, which is the list comprehension. It would be 162 for A out of the sum of all of these here, for the beginning of the name. So then we pass the letters, and those updated weights are just calculated into an NumPy random choice to probabilistically generate the next letter, and we add that to the name. If the next letter is underscore, then we would finish the name, and then if not, then we move the key down. So if it was underscore and we just added A, then it now becomes underscore A, and we want to get the next letter. Note that this will not return anything if we never hit the underscore signifying the end of the name when we exceed the maximum name length. So here is the code that calls this code, which is while we have not generated the number of names that we want, then we generate the name. If we actually return something, then we check to see if it was in the original name. So we take out the last character, which is the underscore, to make sure that it doesn't match one of the names that we had in the beginning. Remember, that was a hash set, so also constant lookup. So if it's not there, then we check if the name meets our length requirements, and if it does, then we append it to our return names, and we eventually return them. So here, I'm going to show you actually running the code. So we've got autumn here, which that's because I didn't have that last character checked. So now we have Millie, Haralaya, Catalyst, Skylin. Seems great to me. So just for fun, let's run the boys, even though I specified female earlier. We got Matt, Darden, Alias. Great.